And then I think that my plan for today, what am I doing? My plan for today is to talk about some of the stuff that you guys were just referencing. So like borrowing and lending and then investing in present value. Um, just to kind of, I want to see how far I got up to last time. Um, was I able to cover, I don't think I covered the reservation wage and how to find it. Maybe you guys can correct me if I'm wrong, but I want to talk about that just real quick because it is something that'll come up um, in a lot of these questions that you see. Um, so I'm guessing by the fact that no one's saying anything that I didn't cover that, which seems right. So I want to talk about reservation wage. We're going to talk about it just real briefly. What it is and then how we find it. So the idea of a reservation wage is essentially each of us, we have different values of how we want to value our time, right? So a lot of it depends on stuff like education or um, your age. So when you're younger and you have not as much education, your reservation wage is going to be lower, which means that essentially you're going to be willing to work for less, right? And so that's kind of how you can intuitively think about reservation wage is like the minimum wage that you'll be willing to work. And so say that your minimum reservation wage is $15, but the most that, I don't know, McDonald's is willing to pay you is $12. You value your time more than you value that $12. And so you're going to decide not to work. But we're going to say that when the wage is above the reservation wage, then we're going to be working some positive amount of hours, right? And that's kind of what the intuition is behind that. Now, as to how you find it, I want to just briefly remind you guys of what the graph is for our labor supply. So we have relaxation on the x-axis and we have consumption on the y-axis. Just a reminder that M plus WL bar, right, is going to be this axis right here, and that this axis right here is going to be L bar. And we know that there's going to be a point right here, which is just going to be M, where this is how much we're going to consume if we are working 0 hours. And so we get something that looks like this. And we're going to say that the reservation wage is going to be the MRS at this point right here. Now, I know that you guys are probably thinking that, well, it's a kink point, so you can't have a slope there. And that's true, but you kind of want to think about the reservation wage as being what the slope would be if there was a slope. So reservation wage, right? And because we can kind of think about it as the slope, another way that you guys can kind of refer back to what slope is, right, and tie it to this point right here, is that because we're dealing with a slope, what we're really dealing with is an MRS, right? And so the reservation wage, is going to be the MRS at the point where we're working 0 hours. So at L bar, comma, M, right? And so these are going to be the values that we're going to plug in for R and C, right? And so let's graph out a possible scenario that we can be working with. So let's just erase this real quick, and then we'll provide a hypothetical scenario. So let's say that we have utility is equal to R squared C, and that P is equal to 1, and M is equal to 30, and that L bar is equal to, let's say, 400. Or actually, no, that's way too high. That's not realistic. L bar is equal to 800. It's one single hundred, right? So given this information, we're actually going to be able to find out the optimal amount of labor and leisure, right? But that's not the question that's being posed in this scenario, right? The question that we're interested in is what is reservation wage? Wage. And let's just say that hypothetically the real wage is equal to 15, right? Well, we know that the reservation wage is basically just the MRS, which is equal to 2C over R, right? So this is our MRS. And we're interested, right, in seeing what it is at the point where we have L bar, comma, M, right? And we can actually plug these values in, right? So this L bar is going to be the value for R, and this M right here is going to be the value for C. And we get that we have 2C, which is equal to M, so 2M over L bar, which is going to be equal to 2 times 30 over 100, right? And so this tells us that our reservation wage is going to be equal to 60 over 100, which is equal to 0.6. And you guys are probably thinking, well, this is a really low value. I want you guys to kind of think about why it is that the value is so low. And then I'll just kind of tell you that the reason why it is that the value is so low is because we have a Cobb-Douglas equation, right? Where you know that part of what we assume about Cobb-Douglas is that averages are preferred to extremes. And so typically, right, because of that assumption that we make, we know that ideally with a Cobb-Douglas equation, we're going to be having a preference to be somewhere in the middle of this constraint where we have some amount of leisure and we have some amount of consumption, right? Which is something that you don't see in this situation, right? Now, if I were to change my value of M, say that instead of 30, M was 300, right? Well, that suddenly changes things to where now I'm plugging in, instead of 30, this is 300. And so now this is 600 and this is 6, right? And so now that makes a little bit more sense. This is a bit more of a reasonable reservation wage, still pretty low. But you can kind of see how if we play around with these numbers, that's going to have an effect on our reservation wage. Another thing that I want to kind of point out to you is that because our reservation wage is less than the real wage that exists, then because of this information, we're going to say that this person is willing to work some positive amount because the wage that's available is higher than the wage that they'd be willing to work for, right? And so that's kind of just a brief introduction to reservation wage. So Rajveer, to answer your question, the reason why we replace M and L bar with C and R is because we want to find the slope at this particular point. And so if you think about what this point is coordinate in terms of its coordinate, this is just L bar comma M, right? And so we want to find the slope at that particular point, which is why we plug in those values. Does that make sense? Yeah, awesome. And so hopefully the concept of a reservation wage makes sense. It should be something that is kind of intuitive to yourself because we all have reservation wage. I'm sure a lot of us have jobs over the summer or maybe even jobs now. And so the concept of how much would I work for has kind of always been a topic of discussion that maybe you don't think about, but it's something that's going on kind of behind I'm trying to, how do I phrase this? It's kind of going on behind the scenes is this thinking. So that's it for this. If there's any questions, feel free to kind of drop them down in the chat. Otherwise, I'm going to move forward and discuss borrowing and lending, and then go into investing in present value. So I'm going to take it that there's no questions and that people feel pretty good about reservation wage. And so that's going to lead me into borrowing and lending. Okay. So before I get into borrowing and lending, I want to kind of just take a step back and give you guys some perspective that'll maybe help you understand what it means to kind of talk about this model, right? So everything up until now has been an allocation between two goods, right? So it was either good one and good two. It was labor, leisure, right? That's kind of making decisions between two goods is what we've been talking about. But now, when we talk about borrowing and lending, and then as we move forward into investing in present value, the two goods that we're going to be making a decision between is consumption in the present versus consumption in the future, right? And the significance between that is that the way that we're going to be exchanging between present and future, right, is going to be dependent on factors like interest rates and inflation, right? We know that from Econ 1, inflation is how much price changes between like two periods. And we know that interest rate is how much a dollar, right, grows between two periods. And so you guys have probably been introduced into the concept, right, of both nominal and real interest. I think that from what you guys have learned, you guys are initially introduced to this concept through the lens of nominal interest, right, where 1 plus r and r is equal to the nominal interest rate, right? I think that this is a useful way of thinking about things, but within the scope of the class, you're hardly ever going to see it where we have just a nominal interest rate. And so I want to introduce the concept, right, of the real interest rate, where the real interest rate is denoted by this variable called rho. So rho is the real interest rate. Whoops. And so we consider this the real interest rate because it's a factor of both the nominal interest rate and inflation, right? So I want you guys to remember this kind of equality that we have here and be able to play around with it, right? And so the reason why we sort of introduce this concept with just this nominal interest rate is because we assume that there's no inflation between period 1 and period 2, right? And if you think about what happens when pi is 0, well, that means that 1 plus rho is equal to 1 plus r when pi is 0, right? And so what's the equation under? Okay, yeah, all right. So essentially, right, we want to kind of be familiar with this relationship, right? But hopefully you guys can kind of make that transition between the nominal interest rate and real interest rate simply by kind of remembering the fact that we divide our nominal interest rate by our inflation rate to get the real interest rate. So I want to kind of talk about that first before we move into anything. So that'll kind of explain why maybe it'll seem like we're moving a little bit faster than usual. But yeah, hopefully you guys can kind of feel comfortable with that. So with regards to borrowing and lending, I want to talk about the two different kinds of people that we have in this scenario, right? We have someone who's a lender, and we have someone who's a borrower, right? And we say that someone's a lender when the amount of money that they start off with in period 1 is greater than the amount that they consume, right? And to kind of clarify, M1, right, you can kind of think about that as the endowment that you have in period one. It's the amount of money that you are just given, right? So you'll see that when we're working in period two, there's going to be a value of M2, and that's just going to be the amount of money that we assume that you already have in period two, right? So the subscripts here are going to be super important because they're going to be what denote the different time periods. So period one and then period two, right, is kind of what we're working with. So because of the fact that they start off with more money than they end up spending, right, we're going to say that M1 minus C1, so this is the difference between what they have and what they spent, right? We're going to assume that this difference gets saved for period two, right? So you'll remember that in the earlier parts of the class, we assumed that we couldn't save any of the money that we didn't spend, right? And so that's the reason why we spent it all, right? In this situation, we're now kind of erasing that constraint, and we're going to say that if we don't spend all of our money, we're going to be able to save whatever we didn't spend and allocate that towards period two, right? And so this, right, this difference right here gets saved for period two, and we're going to say that it grows at the rate of interest, right? So if you imagine kind of how you guys have your own like bank accounts, right? That money is going to grow at a certain interest rate, which is super low right now, just kind of by the way. But we're going to say that M1 minus C1 is going to be multiplied by 1 plus rho, right? And this kind of product is money that we saved in period one times the interest rate, right? And then we're going to say that we add this to M2, and this is going to be equal to consumption in period two, right? Okay, so we're going to consider this our future consumption, all right? Now, let's talk about what it means to be a borrower, all right? Or actually, before we do that, I just want to clarify that in this scenario, our consumption in period one is C1, and our consumption in period two is equal to this whole equation right here, okay? So this is a 1 plus rho. Rho is just like a Greek letter. And this rho, right, if you remember, is equal to 1 plus r over 1 plus pi, all right? So we're assuming that we can kind of take inflation into account when we're looking at this equation. All right, so let's look at what it means to be a borrower in this case. When someone's a borrower, we're going to say that the amount of money or amount of consumption that they have in period one is going to be more, right, than they were given, right? And so what happens when this situation occurs is that we have to borrow from the future. So what I mean by borrowing from the future is you have to take out a loan. And so for those of you guys who are maybe trying to kind of piece this together intuitively, a loan is essentially just money that we owe in the future. And so that is borrowing against the future. That's kind of what we call it, right? And so because we spend more than we have in this period, right, that means that we're borrowing against period two. And so that's going to be money that we're no longer going to be able to spend in period two, right? So we say that C1 minus M1 is owed in period two plus interest, right? So if you guys are familiar with bank loans, which I don't assume you guys would be, but if you guys are, for example, right, we know that when we borrow money, there's a certain interest rate that we're going to have to pay, right, to borrow money, right? And we kind of made this assumption right here that when we save money, there's a certain interest rate that we we get for saving. So this is what the bank pays us in order to save. Now this money right here, right, is money that we're going to owe. And so we owe this amount plus interest, right? And so we say that our future consumption is going to be M2, right? This is the amount that we have in period 2 minus this amount, C1 minus M1. And then we multiply this amount times interest, and that's going to be 1 plus rho, right? And I want you guys to kind of look at what we have right here and see whether there's something you notice about these two equations that maybe is not so obvious just by looking at it at first glance, okay? And maybe I'll give you guys like 10, 15 seconds. You guys can drop down what you think is the relationship between this equation and this equation, right? Down in the chat. All right. And so you guys probably remember this from lecture. And so I'm seeing some people saying that they're the same, right? And so that's kind of the beauty, is that no matter whether you're a lender or you're a borrower, your consumption in period 2 is still going to follow the same equation, right? So C2, right, is equal to this equation, but it's also equal to this equation, right? And so the reason why, and this is just like some mathematical tweaking, is that this is equal to M2, right, plus M1 minus C1 times 1 plus rho, right? And this is C2 equals M2 minus C1 minus M1 times 1 plus rho, right? But if you multiply the negatives through, what you get is M2 plus negative C1 plus M1 times 1 plus rho, right? And if you just kind of flip these two in terms of where they are, what you get is M2 plus M1 minus C1 over 1 plus rho. And you guys are probably confused, or you guys may be confused about why it is that we can kind of make this assumption that the equation is true no matter if you're a lender or a borrower, right? And the reason why is because if you're a lender, this amount is just going to be some positive amount, right? And so your C2 is going to be greater than M2, right? Because you're adding some positive term to M2. However, when you're a borrower, this term right here is going to be negative because M1 is less than C1. And so that assumes that C2 is less than M2. And I apologize for kind of the messy nature of these notes. But hopefully you guys can kind of see what I mean when I write these equations down, is that if you're a borrower, this value will implicitly be negative, and this value right here will implicitly be positive, right? And so that's going to determine, right, what C2 is relative to M2. Also, I'm seeing a lot of comments about why we use rho instead of R. And so I can kind of just say that he uses R as kind of like training wheels to get you guys prepared for 1 plus rho. But I kind of want you guys to get familiar with the fact that we do use rho, because in most problems, we're going to assume that there's going to be some value of inflation that we're going to be dealing with, right? And so, right, to kind of just erase some of this stuff right here and just show you guys again, 1 plus R, so 1 plus rho equals 1 plus R over 1 plus pi. The reason why he uses 1 plus R is because in the beginning, we're going to assume that there's no inflation. And so when inflation is 0, this right here and this right here are equivalents, right? But this equation at least gives us the flexibility to include inflation, right, in a scenario where it's stated in the problem. So I assume that at some point he will maybe include it. I would definitely hope so. But if for some reason he doesn't, I would still learn this because I don't think that it's too hard to kind of adjust from one to the other, right? I think that if you know one plus rho, and if you're familiar with one plus rho, you're definitely going to be able to work with one plus r. Um, but if you know one plus r, you might not necessarily be familiar with using one plus rho. Does that kind of help you guys? So that's kind of the advice that I would give you, is to just get familiar with this, because once you're familiar with this, you'll be familiar with this, right? And I recognize that I'm saying this, and um, yeah. Um, an example of like borrowing and lending, or uh, okay. So hold on. Let's just kind of before. Oh, using the row. Okay, yeah, I can definitely do that. So say R, or typically they won't say it, like they'll kind of just use it in a word problem. But say nominal interest is 10%, and P, and so um, and inflation is 5%, right? Then 1 plus rho is equal to 1 plus 0.1 over 1 plus 0.05, which is equal to 1.1 over 1.05. I don't have a calculator on hand, but this is kind of essentially what 1 plus rho would be, right? So if you want to find rho specifically, you would subtract 1 from this side. So rho is equal to 1.1 over 1.05 minus 1. But typically you can kind of just attach 1 plus rho as like a package deal, right? And so I will give you guys a warning in that the way that he describes what the interest rate and what the inflation rate are might be a little bit tricky to kind of understand. So he might say money in a bank account grew from $100 to $107, right? And this is just like a cheeky way of saying that the inflation rate, or that, excuse me, that the nominal interest rate is 7%, right? Because the rate at which money grows in a bank is the nominal interest rate. So this is just kind of like a tricky way of saying that. A way that he might say inflation is that price of, I don't know, golf clubs in period 1 were $10, but in period 2 they were period $15. And so, right, this doesn't like explicitly tell you what the nominal interest rate is or what the inflation rate is, but from this information, you're supposed to be able to kind of implicitly get that this is what they're asking for, right? And so, right, 1 plus rho in this case would be 1.07 over 1.0 or 1.1.5, because inflation is 50% in this case, right? And so if there's any questions, if there's any questions about how to actually find what this would be, right, you would do basically just new price, so 15, new minus old over old. That's kind of like a classic way of finding like rate of change, right? And so this would be 5 over 10, which is equal to 0.5, right? Is that like a good example that kind of answers your question? I guess that was like a couple examples, but All right. I'm going to take it that that's kind of going to be good enough for that. I do like implore you guys to be familiar with the concept of the real the real interest rate, excuse me, because once you're familiar with the real interest rate, um, if they ask you a question about nominal interest rate, it should be a lot easier. Okay, now that I've kind of told you guys what consumption in period 2 is, right? I want to kind of developed a budget constraint that we're going to be able to work through, or that we're going to be able to work with moving forward, right? Right. So we know that all of this is going to be equal to C2, right? So how we're going to be able to kind of play around with this is, I want you guys to just kind of follow along. I don't think it's important that you know every step, but I do think that it's kind of, I wouldn't say super important, but it'll maybe help you with your understanding to see how we go from here to the budget constraint that you guys have probably already been introduced to, right? So we know that we have this information given to us, right? And we know that we can FOIL this out so that we get M2 plus M1 plus M1 row minus C1 minus C1 row. And then from here, right, this will allow us to kind of pull together like terms. Right? Or another way of doing this is pretty much just distributing, right, the M1 and the C1. But from here, I want to get my consumption on one side and I want to get my income on the other side, right? So we already have income all on this one side. So what I'm going to do is I'm just going to multiply, or I'm just going to add to both sides this term right here. And so I'll get that, and I'm just going to erase this right here. I'm going to get something that looks like this. M2 plus M1, 1 plus row, is equal to C2 plus C1, 1 plus row. All right. And what we consider this, this formula right here is, this is our budget constraint in terms of future value, right? And so the reason that we consider this in future value, right, is because we assume that essentially all of our money gets saved, right? So that our consumption is equal to, right? So let me take a step back. Assuming that all of our consumption is in period 2, right? That tells us that C1 is 0, which means that C2 is equal to M2 plus M1, 1 plus row, right? And so essentially what that tells us is that all of the money that we had in period 1 gets saved at the rate of the real interest rate, and we add that in combination with the money that we get in period 2, and that's going to be how much we're going to be able to consume in period 2, right? And I know that this is probably all a little bit confusing to you guys, and I don't mean it to be, but I think just in general, the concept of like making allocations between time periods is confusing. And so I want you guys to kind of take what I'm saying, right? And you don't have to understand it all, but I want you guys to kind of be thinking about what these equations mean, right, in terms of words. And I've been saying that all quarter long, is that if you're able to kind of read through what this equation says in words, that'll give you a better understanding of what it means, right? Like what's the implication of this, like, and why is it important, right? What I will say though is that this is not the equation that we're going to be working with most of the time. The equation that we're going to be working with most of the time is if you divide everything through by 1 plus row, right? What you get is M1 plus M2 over 1 plus row is equal to C1 plus C2 over 1 plus row. And we're going to consider this present value, right? which means that everything is in terms of what the value is in period 1, right, as opposed to period 2, right? And so the way that we can kind of tell whether it's something is future value or present value is, are we multiplying by 1 plus row, or are we dividing by 1 plus row, right? And so you'll notice that when we multiply through by 1 plus row, you're essentially multiplying everything by the real interest rate, right? And so that is what pushes it into the future, right? I think a way that I can kind of show you this is on a number line or on a timeline. So let's consider this period 1, and this is period 2, right? And let's say that in period 1, we have $1. If we want to see what that dollar is worth in period 2, we push it forward and we multiply it by 1 plus row. So that in period 2, that dollar is now worth 1 times 1 plus row, right? Now, on the other hand, right, if in period 2, I have $1, but I want to see what that dollar is worth in period 1, right? I'm going to push it back, right, and say that this dollar is worth 1 over 1 plus row, okay? And so the reason why is that the reason why we want to have it in terms of present value, right, is because if you think about what it means, right? So if we have some money here, right, we can kind of save it and that'll grow. Or if we have money here, right, you want to see what that dollar was worth in the present, right? So if you think about what 1 over 1 plus row is, if you grow that amount and it grows at a rate of 1 plus row, okay, I guess maybe I'm kind of rambling at this point, but I'll just kind of finish what I'm saying. If you grow this amount and you multiply it by 1 plus row, the 1 plus rows cancel out and it grows into $1. And so this concept just in general is really important for any sort of investing and present value question, because you want to be familiar with how money moves between time periods. And I guess that's kind of all I'll say about that. The main takeaway for you guys, I think, is knowing how I got this budget constraint and how we're going to be able to work through it. And so in the last 10 minutes, that's kind of what I'll be covering. And then maybe I'll rush some stuff at the very end, just to make sure that you guys are getting a good foundation. But the budget constraint that we're going to be working with in the borrowing and lending scenario is going to be the present value. So we have C1 plus C2 over 1 plus row equals M1 plus M2 over 1 plus row. And so we're still going to graph it on a XY axis. X1 is just going to be C1 and X2 is going to be C2, right? And if you think about what these intercepts should be, right, an easy way of doing it is basically just setting the other value equal to 0. So if you want to find what the C1 intercept is, well, C1 when C2 is equal to 0 is just going to be M1 plus M2 over 1 plus row. And same thing for C2, you just set C1 equal to 0, and you get that C2 is equal to M1 times 1 plus row. Whoops, don't want to do that. And that's just going to be plus M2. And we're going to be able to form a straight line from there, where the slope is going to be -1 plus row, right? And so that should kind of make sense because the rate at which we can kind of move between period 1 and period 2 is going to be at 1 plus row, right? And so it only makes sense that this is the slope of the budget constraint. And within this, right, kind of like the buying and selling, if you guys remember that, that was last week's stuff. But within the buying and selling model, right, we had a given endowment, omega 1, omega 2, right? Similarly to that, we're going to have some amount of income in both periods that we're going to start off with. And so this will be M1 and this will be M2. And this amount is not necessarily where we're going to want to end up at, right? And so that's why we have this concept of borrowing and lending, like what it means to be a borrower and what it means to be a lender. So say that we start off at this position right here, except that this is our optimal point, right? Given a certain indifference curve and price ratio. So because of this, right, we're going to say that this person right here, because their M1 was greater than C1, would be a lender, right? And likewise, if M1 was less than C1, then we would call this person a borrower. All right. So hopefully you guys can kind of see how this translates onto a graph. Are there any questions about that? Yeah.
I had a question.
Yeah. What's up?
How do you get from the graph that this person's a lender?
So we know that this person's a lender because we already established that this is going to be their like starting endowment. So this is our starting endowment, which means that they're given M1 in period 1 and they're given M2 in period 2, right? But we know that how much you start off with is not necessarily where you want to end up with, right? And so every point along this budget constraint is what we call affordable, right? And so kind of like any other problem that we work through, we're going to find your MRS and we're going to set it equal to this price ratio, which is this rate right here. And we're going to find an optimal point that's going to be how much we're going to want to consume in each period. So C1 star and C2 star, right? And given that we're going to consume less in period 1 than we had given to us, meaning that our endowment in period 1 is more than our consumption in period 1, that tells us that we're going to have leftover money that we can save and then allocate to period 2, which means that this person is lending their money into period 2. Does that make sense?
That makes sense. Thank you.
All right, awesome. Yeah, and if more people have questions like that, definitely feel free, because I think that you'll notice that a lot of this material is a lot harder than like week 1 to week 3 stuff. And so it's possible that you guys have questions. So I definitely encourage you guys to keep asking.
So if your optimal point is above and to the left of your endowment point, you're a lender, and if it's down and to the right of your endowment point, you would be a borrower, correct?
Yeah, that's exactly right. So this for example, if their optimal point was here instead, then this person would be a borrower, right? That's a perfect way of thinking about it. Yeah. Okay. And so that covers like the meat and potatoes of what I wanted to talk about. So I'll just briefly talk about investing in present value, sort of like quick questions that you may be asked. So this, just to kind of put you guys at ease, this is mostly what they're going to be talking about when they're talking about borrowing and lending and like all that like period 1, period 2 stuff. Especially because insurance is not going to be on the midterm. So just some general stuff, right, is that if we're talking about future value, right, we're going to say that $1 now is worth $1 times 1 plus rho to the t, right, where t is the t time period. It doesn't really make sense. But essentially, right, we're currently working in like period 1 and period 2. So what this really is just an index. So I know that it might be a little bit confusing, but period 1 correlates, or period 1 is equal to time period 0, and period 2 is equal to time period 1. And so kind of the reason why that is because if you think about what it means, right? This is basically on a number line, right? This is period one, but you notice that this is like zero, right? And so this is maybe where I'll be like a little bit confusing because it's more of like an indexing issue that we're dealing with, right? But if you think about 1, 2, 3, 4, so 1, 2, 3, 4 different time periods, right? In words, this would be period 1, 2, 3, 4, and 5. So I just want you guys to kind of be familiar with like the index and what it means. But essentially, money that's grown here, right? This grows at 1 plus rho, and then it'll grow again. So this is like the idea of compounding interest, right? It'll grow at this rate again. So this money that we have right here is 1 plus rho, and then you multiply that again, and you keep doing that for however many time periods we're working with, right? And so that's kind of why we raise it by an exponent that's going to be equal to the time period that we're dealing with, right? And remember that the time period that we're dealing with is different than maybe what it would be called in class. So just kind of be familiar with that. I don't think that this will pop up as much, especially on a 15-question quiz. Yeah, you keep multiplying. You don't just keep adding them. You multiply. Yeah. And kind of likewise, say that we're here, right? We have $1 here, but you want to find the present value. Then you would just do the opposite and just kind of just keep going backwards, right? So you go back 1 period, 2 periods, 3 periods, and 4 periods, right? And so the present value is that $1 in T4 is worth $1 over 1 plus rho to the T4, where T4 is just 4, okay? And so that's like some kind of quick intuition. So in the borrowing and lending, right, model, we're only working with 2 different time periods. But just know that this can kind of be extrapolated to just a bunch of different time periods, so more than 2. So this will kind of just be familiar, like something that you'll want to be familiar with, but you don't need to know like that in depth, I would say. This is more like supplementary stuff, right? And so if we're assuming something, so this is going to be the concept of like net present value. So net present value can be kind of written in this form where we have cash flow 0 plus cash flow 2 or cash flow 1 plus cash flow 2, right, etc. This initial cash flow is the amount of money that we're either going to get or we're going to lose in the first time period. And so you'll notice that because it's in the first time period, we're not going to need to multiply by 1 plus rho or divide by 1 plus rho because it's in the present, right? And so that's why I have it indexed at 0, just to kind of make it more intuitive to why we don't multiply or divide. But you'll see that these other cash flows, we're going to want to divide, right? Because we're finding the present value, right? So this will actually be equal to cash flow 1 divided by 1 plus rho plus cash flow 2 divided by 1 plus rho squared. And so another cool thing about indexing in this way is that these numbers are just going to match up. So the exponent is going to match up with the like subscripts. And so we're going to say that if the net present value is greater than 0, you invest. And so the reason why we are interested in stuff like this is because if you think about how like a real life business would work, so like think of like a startup, there's going to be a lot of negative cash flows that are going to be occurring early on. So you can kind of think about this as like investing in like an office space or investing in workers. So you may get negative cash flows at the beginning, right? But if your cash flows are positive going forward, right, then it's possible that your net present value is going to be greater than zero, right? But because those cash flows are also in the future, you need to divide it by 1 plus rho for whatever index you're at, and then that'll get you the net present value. So I guess, let me see. Here, let's just do a quick example. I know that some of you guys may need to go, and that's all right. I'm just going to do a quick example with like real numbers so that maybe it'll make sense. So let's say that cash flow 0 is equal to negative 500. Cash flow 1 is equal to negative 100, and cash flow 2 is equal to 1,000, right? And let's say that 1 plus rho is equal to 1.2. So there's 20% real interest rate, right? And so plugging all of these numbers into the formula, you would get negative 500 minus 100 over 1.2 plus 1,000 over 1.2 squared, right? And on the test, if you're using a calculator, which I believe because it's take home, you can probably get away with that. This will be equal to negative 500 minus 100 divided by 1.2 plus 1,000 divided by 1.2, whoops, divided by 1.2 squared. And this is equal to 111, right? But what you'll notice is that, right, if you were to simply add up these numbers, right, you would think that your net present value would be closer to 400, right? Because 1,000 minus 100 minus 500 is 400, but the number is actually a lot lower, and that's because values that are further away get impacted more so by the interest rate because of the fact that you're squaring it or you're raising it by 3 or whatever time period, right? So basically, cash flows that are further out are going to be more impacted, and so you want to take that into account. But that's kind of how you would do a problem like this. Just given those cash flows, you would basically just plug in numbers. And so that's all I have for today. If you guys have any questions, feel free to ask. I know that I didn't give you guys a lot of time for questions. It felt kind of rushed, just because I wanted to kind of make sure that I was explaining everything correctly. But yeah, now is the time for questions if you guys have any. Otherwise, if you guys don't have questions, I do have drop-in. Also, one thing that I want to note is that, and shoot, you guys, a lot of you guys left already, but because I have a midterm tomorrow that I am maybe not so ready for, I'm going to push my drop-in tomorrow from 1 to 4, meaning that it'll start at 4 p.m. So, yeah. And I guess just have a good day, guys.
Eric, are you gonna move to the drop-in link, or should I stay here?
It depends. I can answer questions here up until 2. Is your question kind of long?
No. I wanted to ask some questions about this, or like this